Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for covering classes with respect to physics. This is lecture number 4 of a unit atoms. So let's begin with today's class. In today's session, we are going to discuss about the X-rays. Let's look at the how X-ray has been produced and what are its characteristics and properties. So let's begin with the setup to produce an X-ray. So as you can see that there is a one evacuated tube, and within that evacuated tube we have one of the target material with which with which we are going to strike the high velocity electrons. That high velocity electrons will be developed by this filament. This is basically a source of the electrons, and generally with this element we have connected the potential difference. Higher the potential difference, higher would be the energy of an electron, and greater would be the intensity of an X-ray. So this is a pipe where a water has been passed. This water can work as the coolant, so that this target metal do not get heated every time it is going to be heated by the electron. So this is the setup to produce an X-ray. What happens is that when this filament and produce an electron, then this electron will strike this material, and when this material is being struck by this electron, it will develop a certain rays that we call as an X-rays. Now let's check what are the characteristics of that target material, because it is not possible that every material you can set up here and that material can produce an X-ray. That there is a special kind of materials which should possess a certain specific properties, so that it can work as to produce an X-ray. Let's look at the characteristics of the target. The target must have high atomic number to produce the hard X-rays. It should be having a high melting point to withstand high temperature produce. That's why we keep a water and we keep passing water here, that it can behave as a coolant, so that this material does not get melted. Next, it's a high thermal conductivity to remove the heat produced. Certain material, it's in tantalum, platinum, molybdenum, and tungsten serves as the target material. So these are the certain specific materials which can work as an which can work as the atom, or which can work as the target material to produce an X-ray. I hope this is clear. Is it clear? Is it clear? Now, do you have any doubts up till now? Is there anything? Is there? Are you sure? Are you sure? Great. Now, let's look at the certain mathematical calculation from this. So, what we understand is that here an electron would be having certain amount of energy. That is what we call as in kinetic energy. So let's look at this. It's in kinetic energy. That would be converted to the intensity, or we should say an energy of an X-ray. So it's an half mv square, that should be is equals to hf max, and this half mv square has been arrived from this. It's basically the whatever the potential difference we develop, that makes them to move faster or to move slower. So this is equals to half mv square is equals to charge into the voltage. Here the charge is the electron, that's why I have written it's an half mv square is equals to E into V. So if I equate this to first and second, this is hf max is equals to E into voltage, or from this if it's a frequency is maximum, then the lambda will be the minimum. If frequency is the maximum, then lambda will be in the minimum. So it's an hc by lambda minimum is equals to E into V, and from this I can have it's a lambda minimum is equals to 1200 divided by V, where V will be in the volts, and this wavelength available will be in the Armstrong. Always keep this in mind. That's this V should be in the volts. This V should be in the volts, and the lambda that is available, that would be equals to in the Armstrong. I hope this is clear. Is it clear? Is it? Please keep this in mind and keep this noted. I hope this is clear. Is it clear? Great. So, can you do one of the questions based on this? Can you? Great. Let's look at this. Question said that if potential difference of potential difference of 2 into 10 to the power 3 volt is maintained across the anode and cathode terminals of X-ray tube, find minimum wavelength of X-rays that can be produced. So, what has given? They said that a potential difference has been developed. That means a V is given, and that is equals to 2 into 10 to the power 3 volt is maintained across the anode and cathode terminals of the X-ray tube. We need to find out the minimum wavelength. So it's an minimum wavelength. This lambda minimum is equals to 12400 divided by 2 into 10 to the power 3. It's a 2 into 10 into 10 into 10. So this two zeros and this zero has been gone. It's a 124 by 2. It's a 62 by 10, which is equals to 6.2 Armstrong. So you can produce an 6.2 Armstrong wavelength from this setup. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Yes? Okay. Suppose this question has been extended, that in the previous question, in the previous question, find out maximum frequency of this X-ray. How will you do this? So as we understand that it's a V is equals to F lambda. So from this it's a C is equals to F lambda. I am having the lambda minimum. So from this it's an F maximum, that should be is equals to C divided by lambda minimum. That's it. So F max, that should be is equals to C, which is equals to 3 into 10 to the power 8 divided by lambda minimum. What do I received? It's a 6.2 Armstrong. So it's a 6.2 into 10 to the power minus of 10, because it's an Armstrong. So this is equals to 3 into 10 to the power 8 divided by 6.2 into 10 to the power 10. So this is equals to, this is the ratio of 3 to the 6.2 multiplied by 10 to the power 18 Hertz. This is the maximum frequency that we can receive from this setup. I hope this is clear. Is it clear? So can you do this? Can you? Are you sure? Do you have any doubts up till now? Is there anything? Do you have any doubts? Do you? Are you sure? Are you? Great. So now let's discuss the types of the X-ray. So we have basically two types of X-ray, and that X-rays has been categorized based on their penetrating power. So we have basically these two X-rays are would be of soft X-rays and the hard X-rays. When I say soft X-rays, it would be in the wavelength it would be from 10 Armstrong to 100 Armstrongs. They would be categorized as the soft X-rays. And when I say hard X-rays, they would be of zero point 0.1 Armstrong to 10 Armstrong. It is the wavelength. When I'm talking about the energies, it's energy of soft X-rays. It's a 12,400 divided by lambda that we have already discussed, and this would be the same. It's a penetrating power as it is having the higher wavelength. That means its frequency would be lesser, and as frequency would be the lesser, it is having the less penetrating power. While this is having the lower wavelength, and when it is having a lower wavelength, its its penetrating power would be the higher. Soft X-rays can be used in radio photography, while hard X-rays can be used in the radiotherapy. I hope this is clear. Is it clear? Are you sure? Great. Now, let's discuss Moseley's law. Basically, Moseley is a scientist who has given us the relation between the frequency, who has given us the relation with the frequency with atomic number to produce an X-ray. That when we produce an characteristic X-ray spectra, or I should say it's an X-ray spectra. So he has given that if you have been used this kind of atomic number, then this frequencies can be available and something like this. So we this is our requirement, that he said that it's a root of frequency is directly proportional to the z minus v. When I say it's a z minus b, I must say it's a b is a constant. So if I square it, it's a frequency which is directly proportional to the z minus b whole square. And from this f is equals to if I remove the proportionality symbol, then it would be an a into bracket z minus b whole square. Again, a is a constant. If this X-ray spectra is of k alpha for X-ray, then a will be having the value of, it's a root of 2.48 into 10 to the power 15 hertz, and b, that is equals to 1. If they say that this is the X-ray spectra for the k alpha line. I hope this is clear. And if I plot this on a graph of root of f versus z, then it would be a certain kind of straight line, and they cannot start from the origin because this is the intercept that we call b over here. I hope this is clear. Is it clear? Is it clear? Are you sure? So have you noted this? Please keep this noted. Keep this noted. Have you done it? Are you sure? Great. So now let's work for the questions based on this X-ray spectra. The question says that if K alpha radiation, of an element having atomic number Z equals to 42 has a wavelength of 0.71 Armstrong. Calculate the wavelength of corresponding radiation of or four element having atomic number equals to 29. So start working on that. He said that K alpha radiation is there, and when it's a K alpha radiation, its B would be equals to 1, that we have discussed in the last slide only. Atomic number Z, it's 42. At that time, wavelength is 0.71 Armstrong. Now, next time, calculate the wavelength of the corresponding radiation. That means again it they require an K alpha series only. That means B is equals to 1 for an element having Z is equals to 29. So Z is 29 and I need to work for the wavelength. So how will I do this? From the Moseley's law, I am having this relation. It's a root of f, which is directly proportional to the z minus b, and from this it's an f that is equals to z minus b whole square, and from this I can have this, it's a 1 by lambda, which is directly proportional to the z minus b whole square. So this can work as a master relation for me. So let's have a walk. It's a 1 by lambda 1 is equals to z1 minus b whole square. It's a 1 by lambda 2 is equals to z2 minus b whole square. So if I take a ratio of this, this will be it's a lambda 2 divided by lambda 1 is equals to z2 minus b whole square divided by z1 minus b whole square. So this will be equals to lambda 2 divided by lambda 1. It was 0.71 again Armstrong. That would be equals to z1, a first element. First element was having a 42. Yes, it's a 42 minus 1 whole square divided by a second element. Second element having it's a 29. So this is 29 minus 1 whole square. From this, it could be written as a lambda 2 by 0.71 is equals to 42 minus 1. It's a 41 whole square divided by 29 minus 1. It's a 28 whole square. So this is lambda 2, which is equals to 0.71 multiplied by 41 square divided by 28 square. This is equals to 1.52 Armstrong. This will be the wavelength, and that can be calculated very easily from the help of Moseley's law. I hope this is clear. Is it clear? Is it? Are you sure? Great. So now can we move to the next? Can we? Let's look at this. It's an absorption. It is the absorption of X-rays. So let's look at this. This is let's suppose we can say thickness having any element, and the thickness is x, and let's suppose an X-ray that has been incident on it having the intensity I naught, and when it passes after this thickness x, its intensity has been changed, and initially it is I naught and finally it is I. So let's look how this I and I naught is dependent with each other. So when X-ray passes through x thickness, then its intensity could be given as I is equals to I naught into e to the power minus of mu into x, where I naught, it is the intensity of incident X-rays, and I, it is the intensity of X-ray after passing through x distances, while mu is the absorption coefficient of a material. As from this we can conclude that intensity of X-ray decreases exponentially. It is an e to the power minus of mu x. I hope you understand this. Yes. And maximum of absorption of X-ray could be from lead, and minimum absorption from the X-ray would be due to air. So please keep this note. It's an I is equals to I naught into e to the power minus of mu x. I hope this is clear. Is it clear? So are you ready for the question? Are you? Great. Let's have a look. The question says that intensity, if the intensity of an X-ray become I naught by 3 from I naught by 3 from I naught after traveling after traveling 3.5 centimeter inside a target, find its intensity. Find its intensity after traveling next 7 centimeter. How will I do this? What is to be done? They said that if the intensity of an X-ray becomes I naught by 3 from I naught after traveling, so when X is equals to 3.5 centimeter, its new intensity will be equals to I naught by 3. And when you want that find its intensity, you required an I dash after traveling next 7 centimeters. So 3.5 centimeter it has been already walked, and you want the next centimeter, so this is a total distance would be equals to 3.5 plus 7. I hope you understand this. So let's try to do this. What I can write, it's an I is equals to I naught into e to the power minus of mu x. So this is equals to I naught by 3, which is equals to I naught into e to the power mu into minus of 3.5. So this I naught has gone, and it's a 1 by 3, which is equals to e to the power minus of mu into 3.5. I hope this is clear. Is it clear? Is it? Great. So please, this is our first relation. Keep it in mind. We might use it. Now, what I want is that I is equals to, or I dash is equals to I naught into e to the power minus of mu into x. So this is equals to I naught into e to the power minus of mu into this x. This x was 3.5 plus 7. So basically it's a 3.5 into 3. Yes. So it's a 3.5 into 3. Now look at this very carefully, that if I am having this relation, I can write like this: I naught into e to the power minus of mu into 3.5 to the power 3. If you are bit confused with this, that let's understand, let's suppose it is x to the power 6 for understanding purpose. Can it be written as x cube into x cube? Yes. So can I write like this to it's an x3 to the power 2? I hope this is clear. Now you understand this. This 3.5 into 3 could be written as minus of mu into 3.5 total power 3. So from this we understand this is equals to I naught into e to the power this. And when I say e to the power minus of u mu 3.5, it is having a value of 1 by 3. So this is total 1 by 3 to the power 3. This could be written as I naught by 27. I hope this is clear. Is it clear? Is it? Now do you have any doubts? Is there anything? So can you do this kind of questions? Can you? Can it be done? Can it be? Can it be done? Are you sure? Great. So let's discuss the properties of X-ray. This has been asked based on the theory questions. So please keep this in mind. X-rays always travel with the velocity of light in straight line because X-rays are EM waves. When I say EM waves, they are the electromagnetic waves which travels in always in a straight line. X-rays is an electromagnetic radiations. It shows the particle nature as well as wave nature. It represents the both the natures. In reflection, diffraction, interference, and refraction, X-ray shows the wave nature, while in photoelectric effect, it shows the particle nature. Next, there is no charge on X-ray, thus there is no deflection of X-ray by electric or magnetic field. X-rays are invisible, and X-rays affect the photographic plate. When X-ray incident on the surface of a substance, it exerts a force and pressure, and it can transfer energy and momentum. A characteristics X-ray cannot obtain from hydrogen because the difference of energy levels in the hydrogen is very small. So these are the properties of X-ray. You should keep in mind. Certain kind of questions has been asked, as well as if you are a student of class 12, this can be asked in your board examinations too. Yes, so let's just wind it up this session over here. This was all about the X-rays. We have covered everything that can be asked in the competitive examinations, whether it would be of JEE mains or whether it would be of NEET examinations. So it is having a very little formulas and little information. Please go through this thoroughly, because even if one of the questions of the X-rays has been asked, even if one of the questions from the X-rays has been asked, we must be we must be able to do this. And this is the last class of atoms too. So please revise the atom carefully. It is having the capability to produce at least two questions in any of the examination. Please go through the previous year questions. You will find it that it has given two questions on each year. One of the questions from the generally hydrogen spectrum series, and one more from the atoms, Bohr's model, and sometimes from the X-rays too. I hope this is clear. So please go through it. This will help us to crack the exam. Thank you. Have a good day. Take care.